Hey guys, Travis here. This is mock exam number two. We didn't do as very good, or we didn't do as good as I thought we were gonna do, guys. I do admit that this exam comes at you fast and hard. It just comes right at you and hits you, and it's like, okay, you either know it or you don't, and you have to recall information really fast. But it's doable. It's doable. You just have to really understand what you're doing. And I think we're going to do better on the next mock exam. So let's, please, guys, make sure you're doing calculus every day. We only got 2 weeks left. This is not my exam. This is an exam created by Brian Passwater. And let's get right into it. So I got my calculator in the background. It's recording, and I think we're good. So here's what it starts off. You don't have enough space, guys, to write on the document itself. At least I don't think so. So you can see that I readjusted it in A, and I apologize if the font size doesn't look correctly to you guys, because all I did was copy and paste to shorten the time. So before I start, I notice or I recognize that I have the graph of f prime, and I have regions of areas. So 5, 11, 7, 3, and 4. And this number here is 9 right there. Okay, let's read this question here. Let g be the function defined by g of x equals, and it's a piecewise function, f of x squared minus 5 for x less than or equal to 3. We don't have that. That's f prime. And 5 minus 2x for x greater than 3. So that's what gx is. The function f is twice differentiable on the closed interval negative 2 to 10 and satisfies f of 6 equals negative 4. So we're probably going to need that later on. The graph of f prime, the derivative of f, is shown in the figure above. The graph of f prime has horizontal tangents at 2. So here's 2. At 5, so here's 5, and at 8, so here's 8. And then one more time at 9. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. Okay. Show that g is continuous at x equals 3. Alright, guys. To show that you're continuous anywhere, it's this definition. So the limit as x approaches 3 from the left-hand side of g of x must equal the limit as x approaches 3 from the right-hand side of g of x, which must equal g of 3. All right, so it looks like I can do the 3 one pretty quick from the right-hand side, so I'm going to start with that one. Limit as x approaches 3 from the right-hand side of the expression 5 minus 2x. That I can just do direct substitution. 5 minus 2 times 3, that's a 6 there. 5 minus 6 is negative 1. No need for a calculator there. Alright, so now I'm going to do the left-hand side. Limit as x approaches 3 from the left-hand side is going to f of x squared minus 5 is going to give me f of 3 squared is 9. 9 minus 5 is 4. So now I have to calculate what f of 4 is. So I come here to the side, and I'm going to put semicolon. I'm going to put, let's see, what am I going to put? F of 4 is going to equal to, and I could use, there's 2 ways to do this, guys. Okay, there's 2 ways to do this. I'm going to erase this right here. Here's one way to do it. So one way. So you can say integral from 4 to 6 is negative 3 of f prime. 4 to 6 of f prime of x is, let's see, negative 3. See, I started at 4 and I go to 6. This area right here, this is f prime. Well, that is f prime. See, area under the curve from 4 to 6 is negative 3. Well, all this really here just means is antiderivative. So I can rewrite that as, I can rewrite this as antiderivative f of 6 minus f of 4 equals negative 3. And I already know what f of 4 is. Oh, no, not f of 4. That's what I'm looking for. I already know what f of 6 is. F of 6 is negative 4. So negative 4 minus f of 4 equals negative 3. So I'm just going to swap these two here. So negative 4, let's see. Well, that was minus, so it's going to turn to a plus. And then that minus a negative, so it's going to turn to a plus. So negative 4 plus 3 equals f of 4. So there it is. So f of 4 is simply equal to negative 1. Cool? Cool. Well, since my limit from the left-hand side of this equals negative 1, so we're looking pretty good, as you can see here. Now I got to check, let's see, g of 3, well, g of 3, if I plug in a 3, you'll get back to this expression, is going to be f of 4, which is negative 1. So I'm going to write since, let's see, since limit as x approaches 3 from the left-hand side of g of x equals limit as x approaches 3 from the right-hand side of g of x, which equals g of 3, which equals negative 1, comma, g is continuous at x equals 3. All right, I told you this was one way to do it, guys. Another way to do it is if you would have said f of 4 is equal to the position that they gave you, which was f of 6. Oh man, what's going on there? F of 6 plus the integral from 6 to 4 of f prime of x dx. You could have also done it this way. F of 6 is, where are you? F of 6 is negative 4 plus, and then 6 to 4, let's see, 6 to 4, that is 3, because it's below, well, because I'm counting backwards. Negative times a negative is a positive. And you would have gotten the same answer. See? All right, guys, let's keep going. I hope that made sense. I put the same problem again, guys, or the same intro because you need it a lot of times. And you can see how much space that took up. So I don't think the exam had enough space for you to write all that. All right, let's go right to letter B. Find the absolute maximum value of f on the interval negative 2 to 10. Justify your answer. Okay, this is a good one for candidates test, guys. So I need my critical numbers. So I need where that happens. And yes, I know that from positive to negative, I have a max. So I don't have to look at negative to positive, and then your endpoints. So a lot of you guys forgot to test your endpoints. So here we go. I'm going to write x, and I'm going to write f of x. And I'm going to explain how I'm going to get my f of x values in a little bit. So x, and we start at negative 2. So negative 2. And then let's see, where does this happen? Where do I have a 0? I have a 0 at 0. So where does f prime equal 0? Well, this is f prime. So that happens at 0, that happens again at 4, that happens again at 6, that happens again at 9, but 9 is not really anything in particular, and that's it. So I'm going to put 0, 4, 6, and I'm tempted to not put 9, guys, but it is a critical point, so just put it, and 10. All right, the value that we know is f of 6, that's negative 4. So I'll put a negative 4 in there. And immediately, let's see, I change from positive to negative. So 4 is the candidate, 6 is not. Oh, that's the only one we have there. And 9 is not, and 0 is not. So I'm going to put NA. Actually, you know what? I'm going to still calculate it, but this is not applicable because that's a min, and they wanted a max, absolute max. Negative, let's see, negative, and all right, so let's just start. So how am I going to find these values? So I guess I'm going to go first this way, guys, to the left, 4, 0, negative 2. So f of 4, actually I already know f of 4. F of 4 is negative 1. F of 4 is negative 1. So there it is. And then from 4 to 0, that area is 11. So look, I'm going backwards, guys. So if I'm going backwards, then that means at 0, that has to be negative 12, because the negative 1 minus 11. And then from 0 to negative 2, that area is 5. But since I'm going backwards, that turns to a positive. So 12, 1, 2, 3, 4, 5. So I think that's a negative 7. All right, I've got all those figured out now. Now let's do the 9 and the 10. So at 9, let's see, at 9 you're right here. And so now I'm counting just regular. So I'm going to add 7 to whatever value I had in there. So what value did I have there? Negative 4. So negative 4 plus 7, 4, 5, 6, 7. That's a 3. And so now I'm going to do the 10 value. So I'm going to add another 4 to that last value that I did. Because from 9 to 10, I'm going to add 4 to it. So let's see, 4, 5, 6, 7. So 7. So in case you're confused, guys, think of this as position, the f of x, and x as the time value. So, and you got to show, okay, so right now I will not get full credit. I got to show how I got these. Show how we got these values. So real quick, I'm just going to say f of x is nothing more than f of 6, which is what we had right there, plus the integral from 6 to x of f prime of x. And that's really how we got them. That's how we got all of them. So, and that's enough right there, guys. If you want, you can even put this here in the top instead of f of x equals f of 6 plus whatever. And that's how I got all of these. And all I did was just literally add. So I'm gonna show one just for example. Look at f of 9. F of 9 equals, I'm really not writing super awesome. F of 9 equals f of 6, which was -4, plus the area under the curve from 6 to 9 of f prime of x dx. Well, -4 plus the area from 6 to 9, let's see, here's 6, here's 9, that's 7. So I went -4 plus 7, and well, that gave me 3, OMG, see? All right, justification, what's the absolute max? Absolute max is 7, the value. So I'm gonna write absolute max value of 7 occurs at x equals 10. And there it is, guys. I hope that made sense. That's full credit. I'm showing how I got my f of x values. There's my table of x and f of x. And I'm good, guys. If you want to show each one individually, that's fine. But you must have this expression somewhere. I would probably put that expression maybe even like f of x equals and write it out here in the top. I didn't show that because I'm in a time limit here. Excuse me. All right. This is one that I don't think anyone got right, or maybe just one of you, or maybe two of you. For x is not equal to 3, the function k is defined by k of x equals some function here. Something on the top, something on the bottom. It is known that the limit as x approaches 3, k of x can be evaluated using L'Hopital's rule. That's a huge hint. Huge hint. Find f of 3. Oh, look, that's another hint. And evaluate limit as x approaches 3 of k of x. Okay, because I can use L'Hopital's rule, that means, what does that mean? That means that 3 integral 4 to 3x of f prime of t dt minus 4x equals 0. And limit as x approaches 3. That means that. Let's see if we can get anything from this. Let's see. 3. Sorry, guys. 4 to 9 of f prime of t dt minus 4 times 3, which is 12, equals 0. 4 to 9, I think I do have that. Nope, I don't. 4 to 9, -3, 7, 1, 2, 3, that's 4. So this gives me 3 times 4 minus 12 equals 0. Okay, that doesn't give me anything. Let's go to the one on the right-hand side. So I probably should have stuck to my guns here where it said this is a hint here. Limit as x approaches 3 of 3e to the 2f of x plus 5 minus x equals 0. This is a true statement because it tells me that I can use L'Hopital's rule here. So let's go ahead and plug in a 3. 3e to the 2f of 3 plus 5 minus 3 equals 0. Now I have, let's see, what do I have? I'm going to move this 3 to the right. So now it just becomes algebra, guys. 2f of 3 plus 5 equals 3. Divide. So I have e to the 2f of 3 plus 5 equals 1. And now that I have that equals 1, guys, look, there's an e there. So I can do ln to bring this expression down. So ln. So now I have this. I'm going to come over here. 2f of 3 plus 5 equals ln of 1, which is 0. And I'm just going to solve for f of 3, guys. So let's see. 2f of 3 equals negative 5. Divide by 2. So I have f of 3 equals negative 5 halves. All right. So we got that out of the way. So now we're going to use L'Hopital. So we're going to take derivative of the top and the derivative of the bottom. Because look, we got 0 over 0. They told us that. So let's see. We're going to take derivative, guys. So let's see if we can. And I'm going to do it in blue because see how I've already taken up most of this paper here, guys? So I'm going to write, let's see, limit as x approaches 3. This is using L'Hopital. Using L'Hopital. And I'm taking the derivative of the top. So let's see. 3 times f prime of 3x times 3. So that's going to turn that 3 into a 9. So 9 f prime of 3x minus 4 over. And then the bottom, we got to use chain rule, guys. So 2f of x plus 5, the derivative of that, well, the derivative of 3e to anything is that 3 to anything, but then you got to do chain rule. So the derivative of 2f of x is 2f prime of x. So 3 times 2 is 6. So 6 f prime of x, that's chain rule, e to the 2f of x plus 5 minus 1. All right, so now let's plug in a 3. When I plug in a 3, I get 9 f prime 3 times 3 is 9 minus 4 over 6 f prime of 3. And then let's see, e to the 2 times f of 3. And f of 3 we already know is 5 halves. So I'm going to write 2 times negative 5 halves, negative 5 halves, plus 5. Oh man, these guys are tricky. Look what's going on there. Minus 1. So right here, these twos are going to cancel out, and you're going to get negative 5 plus 5, which is 0. E to the 0 is 1. F prime of 3, I got it from here. F prime of 3 is 3.5. So here's what I have. So I have 9 times F prime of 9. F prime of 9, this is 9, that's 0. So 9 times 0 minus 4 over 6 times f prime of 3. And f prime of 3 is 3.5 times 3.5 minus 1. And actually, you actually don't even have to simplify it, guys, but I'm going to simplify it. Let's see, negative 4 divided by parenthesis 6 times 3.5, whatever that is, minus 1. And I got negative 0.2, or negative 1/5. There it is. Those guys, they're so funny. Mr. Passwater, you're a funny guy. Alright, let's go to the next one, guys. It looks like there's a little bit of that 2 missing when I was doing cut and paste. My bad. Alright, let y equals h of x be a function such that dy dx equals f prime 2x times 3y minus 1, where y is greater than 1/3. Find the second derivative and use this expression to determine if the graph of h of x is concave up or down at h of 1 equals 2. Alright, that's fine. It looks like I'm going to need my first derivative anyway, so I'm going to plug in that value. I'm going to plug in 1, 2. Why did I do that? So dy dx evaluated at 1, 2 is f prime 2 times 1 times 3 times 2, excuse me, minus 1. So f prime of 2, 3 times 2 is 6, 6 minus 1 is 5. F prime of 2 is 5. So 5 times 5 is 25. Okay, so now I'm ready for the second derivative. So I need to use product rule. So second derivative is first. And I know some of you guys already do the first with 3y minus 1. It's the same thing, guys. 2x. So I'll go to the second. So the derivative of the second is 3 dy dx plus second times root of the first. So chain rule, 2f prime of 2x. All right, there it is. I'm going to start plugging in. So the second derivative evaluated at 1, 2 is nothing more than f prime of 2 times 1. So that's going to be 2 times 3 times dy dx, and my dy dx was 25, so 3 times 25 is 75. Plus, let's see, 3 times 2 is 6, minus 1 is 5. And then at 2 times f prime of 2. And f prime of 2 was what again? Man, short-term memory. I'll just write f prime of 2 since I already have f prime of 2 over here. All right, let's see what this is. F prime of 2 is 5. So 5 times 75. Come on, buddy. 5 times 75. So 375. And plus 5 times 2. Oh, man, guys, I almost made a huge mistake. This guy right here, I took the derivative, but that's supposed to be second derivative. Because I was wondering why that said prime and that said prime. First times root of the second plus second times root of the first. So error, there's my error. Fix it, guys. I just fixed it. Fixed. So that should be f prime prime. All right, f prime prime of 2. Sorry, guys. F prime prime of 2. So my second derivative of 2, that's 0. So 5 times 0. So there it is, 375. And because my second derivative is positive for h, so let's see, yeah, my second derivative is positive at 1, 2, hence concave up. So I'm going to have to write that. So since, let's see, since second derivative is positive at 1, 2, comma, concave up at that specific coordinate. I hope I didn't confuse you guys. I caught my own mistake because I knew something was up. It just looked weird because when I did the product rule, I'm not supposed to have 2 f primes. There's supposed to be 1 f prime and one that's supposed to be a derivative of f prime. All right, let's keep going. Letter E. It says, consider the function in part D between -1 and 5. On what intervals is the function h of x increasing? All right, that's simple. H of x is increasing whenever the derivative is positive. So let's see. Let us talk about dy dx. Excuse me. Dy dx is equal to, and I have f prime of 2x times 3y minus 1 from up here. F prime of 2x times dy minus 1. So I need this guy to be positive. So they already told us, guys, in the stem of the question or embedded in the question right here that y is always bigger than 1/3. If y is always bigger than 1/3, that means this expression will always be positive. So we focus our attention on f prime of 2x. Focus on f prime of 2x. I need f prime of 2x to be positive for h of x to increase. That's the only thing that I got to worry about. I need f prime of 2x to be positive. Now here's the issue. This is not f prime of 2x. Not f prime of 2x. This is f of x, guys. This is f of x. So they're testing to see if you know your algebra knowledge. So let's see. Let's go ahead and draw, since I already color coded, blue is f of 2x, f prime of 2x. Let's draw how f prime of 2x looks. If that's 4, then at 2, I'd better be touching there. And then let's see, if that's 2, 5, then at 1, I'm at 5 right here. 0, that's still there at 0. If that's 6, then I have another 0 there. Let's see, 5, so that's 2.5, so 2.5, I'm like right here. And let's see, 10 up there, so then that's 5 right up here. And that's 9, so I have a 9, that's 4.5, so 4.5 point. Alright, and well, I guess let's do this one. Negative 2 is negative 1, so negative 1 point. So here's how it looks, guys. Looks like it's not calibrated perfectly. Looks like this. Oh man, I'm gonna have to. Nope. Let's see, that's 3 because of the 6, and then the 9 is the 4.5. Oh, okay, I'm missing this one. 6, 7, half a 7, 3.5. I messed up. There we go. Sorry, guys. That took longer than it needed to take. It's this graph squeezed in by a factor of half. It doesn't look perfect, guys, and I apologize that it doesn't look perfect. But all right, but now we can tell. So since we just got to focus on where f prime of 2x is positive, well, I'm just looking at my graph in blue. It's positive from 0 to, that looks like a 2. And then it's positive again from 3 all the way to 5. So there it is. Those are my answers, guys. So so you're going to say, what are you going to say? 0 to 2 and 3 to 5. All right. So let me write that down. H of x is increasing. I don't know why it's not on the intervals 0, to 2 and 3, to 5, since this is where f prime of 2x is positive. Kind of want to add in these specific intervals, but that's fine right there. All right, guys, let's go to the next one. All right. It says, consider the differential equation for part D. Use separation of variable to find a general solution to y equals h of x from the form ln 3y minus 1 equals... Okay, so I don't even need all this stuff here, but I went ahead and put it in there just in case. So my equation from part D, it's the same differential. F prime 2x through 1 minus 1. Okay, so it's this one. It's this one here. So I have, let's see, what do I have? dy dx equals, I already forgot. F prime 2x through 1 minus 1. F prime 2x through 1 minus 1. F prime 2x 3y minus 1. Okay, separate your variables, the x's with the x's, the y with the y's, but leave the f prime alone. So I'm going to write dy over 3y minus 1 equals f prime 2x dx. You did that, that's probably a point. So now I'm going to integrate. So this becomes ln absolute value 3y minus 1. Now if I took the derivative of this, it would have been times 3, so I have a 1/3 in the front, equals, and then the antiderivative of f prime is f. So I'm going to write f of 2x, and I would have had a 2 in the front, but I don't, so you got to write half. I mean, I don't have a 2 in the front of this antiderivative, so it's a half, and then plus c. And now, since I don't have anything in front of this ln, see how it's blank? I'm going to multiply everything by 3. So ln 3y minus 1 equals 3 halves f of 2x plus c. And there it is. Your a value is 3 halves. Your b is 2. And there, that's it. Alright guys, so it didn't look like we used our calculator much on that one. Alright, this one here. So we have a large pizza chain. So let's see if we can understand this. First we have hours and we have cost per hour. So this is in hundreds. So that really means that's 500, that's 450, that's 250, that's 100, and what's that, 20? 0.2 times 100. Right? 0.2 times 100. 20. Alright. Sorry guys, I'm not insulting your intelligence there. A large pizza chain delivers pizza nightly from 6 to 2. On a Friday night, the rate of the pizza chain receives cost for delivery is modeled by the differential function c prime of t, measured in hundreds of cost per hour, and t is measured in hours since 6 p.m. So that's the value of c prime are given in the table above. Use the data in the table to approximate c prime prime of 7. Using correct units, interpret the meaning of c prime prime 7. Alright, 7 is between 6 and 8. So I'm going to write c prime prime of 7 equals 0.2 minus 1. I guess what I'm doing first, let me rewrite what I'm doing. I'm doing c prime of 8 minus c prime of 6 divided by 8 minus 6. C prime of 8 is 0.2 minus z prime of 6 is 1 over 8 minus 6. What's that, 2? So I'm just going to use my calculator, guys. 0.2 minus 1, I know that's 0.8, negative 0.8. And I'm going to divide that by 2. So there it is. Negative 0.4 cost per hour per hour. Cost per hour squared. Alright, using units, using correct units, interpreting the meaning. Alright, so let's see. The rate of cost in cost per hour. The rate of cost per hour is decreasing. The rate of cost per hour is decreasing by 0.4 cost per hour at t equals 7. The rate of cost per hour is decreasing by 0.4 cost per hour at t equals 7. Perfect. All right, let's go to the next one. Do the data in the table support the conclusion that there is a time between 0 and 8 at which a pizza chain receives 300 delivery calls per hour? Give a reason for your answer. Oh, yeah, of course, right here. Right there. So I would say probably something like c prime of 1 equals 450. And then I would probably go c prime of 4 equals 250. And then I go, there exists a time t somewhere for 1 less than equal to t less than equal to 4, where c prime of t equals 300. And I guess I should put units here. Cost per hour. Cost per hour. Cost per hour. There is this time t somewhere for 1 of 4 where c prime t equals 300 cost per hour by IVT. Perfect. I have two numbers here, or two scenarios. I have a max and a min of one number that's bigger than 300, one number that's bigger than 250, then 300. One number that's bigger than 300, one number that's smaller than 300. Perfect. And then I can just say by IVT, but I gotta make sure that I mention that. There is a time t somewhere for 1 of 4 where c prime of t equals 300 cost per hour by IVT. Perfect, guys. All right. I think you might even get the credit if you don't say IVT in there, but it'd be nice if you did. All right. Using correct units, explain the meaning of the definite integral 0 to 8 c prime of t in the context of the problem. Okay, well, cost per hour, use your units. C prime is in cost per hour and dt is in hours. Cost per hours times hours is cos. So in the context of the problem, 0 to 8 C prime of t dt is the number of calls received from t equals 0 to t equals 8. If you want to say 6 p.m. to 2 a.m., that's fine. Let's see. Use a right random sum with 4 subintervals indicated in the table. Okay, so 4 subintervals. Here's my first, here's my second, here's my third, here's my fourth. You're going to have rectangles because all you have, guys, if you were to plot this, 0, 5, point, 1, 4.5, point, 4, 2.5, point, 6, 1, point, 8.2. So all you're doing is this. Here's your rectangle. First rectangle, second rectangle, third rectangle, fourth rectangle. Sorry that they're all pretty small. I should have probably made them bigger. So that's all you're doing, guys. You're just finding the area of those rectangles, and it says here that it wants a right Riemann sum. So let's do a right Riemann sum. So width is 1, height is 4.5. So integral 0 to 8 of c prime of t dt is approximately 1 times 4.5 plus, let's see, the difference between 1 and 4 is 3. 3 times 2.5. Now I'm using this number. Then the difference between 4 and 6 is 2. So 2 times 1 plus, and the difference between 6 and 8 is another 2. 2 times 0.2. All right, let's see what that is. So I'll take my little calculator. And I'm going to go 4.5. Oh, come on, buddy. 4.5 plus 3 times 2.5 plus 2 plus 2 times 0.2. Push enter and I get 14.4. So that's how many calls you get. So you get times 100, so 1,400, I guess hundreds of calls. Hundreds of calls from t equals 0 to t equals 8. You could also say 1,440. And I think that's it, guys. All right, let's go to the next one. The total number of calls that the pizza chain receives for delivery on Friday night and hundreds of calls can be modeled by the function f given by that function, where x is the number of delivery drivers. When there are 60 drivers, the number of drivers is decreasing at a rate of 7 over 24 drivers per hour. So that's the ddt. Remember, that's decreasing though, so it's negative. According to this model, what is the rate of change of total delivery calls with respect to time in hundreds of pizzas per hour at the time when there are 60 drivers delivering? Okay, that means take derivative, because this is a number of hundreds of calls. So if you want the number of hundreds of calls per hour, we're going to have to take the derivative of this. So here we go, df dt. So bottom, 200 minus 2x, 100 at the top, 2x dx dt. We're taking the derivative with respect to time, guys. Minus the top, x squared, 100 to the bottom, negative 2 dx dt, all over bottom squared. I wouldn't even bother. Well, I guess you could simplify, but I'm not going to do that. I'm just going to go 200 minus 2 times 60. That's what x was. And then 2 times 60 times my dx dt was negative 7 over 24. I put parentheses not to be confused for a minus. Minus, and then 60 squared times negative 2 times negative 7 over 24. So negative times a negative times a negative is a negative, so you can just leave it as negative there, or minus. And then 200 minus 2 times 60, and then whatever that is squared. Alright, so I'm just going to use my calculator, guys. I'm not even going to bother. So here's my calculator. And make that smaller so I can see all of it. Alright, so let's see. Alpha y equals, enter. open parenthesis, and come on, buddy, 200 minus 120. I can do that mentally, no big deal. Close, open, and then 2 times 60, that's 120. So 120 times a negative 7 over 24, close, and then close, minus, and then open, 60 squared. I guess I could have put the square on the outside there, times negative 2 times negative 7 over 24. And I guess I didn't have to do, oh, look at all these little mistakes here. 7 over 24, close, all over, if I didn't do any mistakes, 200 minus 120 squared, enter. There we go. I think that's the correct answer, guys. Negative 49 over 64. Negative 49 over 64. In hundreds of pizzas per hour. In hundreds of pizzas per hour. When there are 50 drivers. You don't have to add that, but this is the answer right here. Make sure you put negative in the front. Oh, that's it. We finished. Yay! All right, guys. Hopefully you guys enjoyed it, and give it a thumbs up if you enjoyed it. And I'll talk to you guys, or I'll see you guys soon. Later.